Have you ever wondered about the possibilities of manipulating matter at an atomic level? This is where the journey of nanotechnology began, in the imaginative minds of scientists who dared to dream small, really small. The inception of this revolutionary field can be traced back to 1959, when physicist Richard Feynman delivered a visionary lecture titled "There's Plenty of Room at the Bottom." He proposed the captivating idea of manipulating individual atoms and molecules, setting the stage for what would later become nanotechnology. In the following years, researchers made significant strides in realizing Feynman's vision. A notable milestone was the invention of the scanning tunneling microscope in the early 80s. This remarkable tool allowed scientists to not just visualize, but also manipulate structures at the nanoscale with unprecedented precision. And thus, the foundation was laid for a revolution in science and technology, opening up a world of possibilities limited only by our imagination. But how do we manipulate something so small that it's virtually invisible? Well, nanotechnology has an answer for that. It's all about using two main approaches: top-down and bottom-up fabrication methods. In the top-down approach, we start with a larger material and whittle it down into nanoscale structures, much like a sculptor carving a statue from a block of marble. This is where techniques like lithography come into play, allowing us to etch intricate designs on the nanoscale. On the other hand, the bottom-up approach is more akin to building with Lego bricks. But here, the bricks are individual atoms and molecules. Molecular self-assembly and chemical vapor deposition are commonly used techniques in this approach, allowing us to construct nanoscale structures atom by atom. By manipulating matter at such a minuscule scale, we're not just shrinking things down, we're creating new materials and devices with extraordinary properties. These techniques have opened up a world of possibilities at the nanoscale. Now, you might be wondering, what's the big deal about the small scale? Well, let's dive into that. Nanotechnology is revolutionizing numerous fields, starting with electronics. Here, it's enabling the creation of tinier, quicker, and more efficient devices, like nanoscale transistors and memory storage gadgets. Imagine data storage devices that can hold 1,000 times more information in a fraction of the space. Next, we see nanotechnology's transformative impact on medicine. It's paving the way for targeted drug delivery, personalized treatments, and advanced diagnostic tools. We're talking about medicines that can specifically target diseased cells, leaving healthy ones untouched. Then there's materials, science, and energy. Nanomaterials with enhanced properties such as strength and conductivity are shaking up industries like aerospace and automotive. Meanwhile, in the energy sector, nanotechnology is helping us to harness renewable resources more efficiently. Clearly, nanotechnology is making a big impact in our world. It's a small-scale science with grand-scale potentials. With such incredible potential, what does the future hold for nanotechnology? While we marvel at the possibilities, we must also acknowledge the challenges that come with this revolutionary science. Environmental impacts, health risks, and ethical considerations all are significant hurdles that need to be addressed. But fear not, for our researchers are not deterred. They're actively tackling these issues, conducting responsible research, establishing regulatory frameworks, and implementing risk assessment protocols to ensure nanotechnology's safe and sustainable development. As we gaze into the future, nanotechnology holds the promise of addressing some of the most pressing global challenges. Imagine harnessing the power of the nanoscale to produce clean energy, purify water, and treat diseases. These are not mere fantasies, but tangible goals within our reach. As we continue to unravel the mysteries of the nano world, who knows what amazing discoveries await us? The future of nanotechnology is bright, and we're just getting started.